Welcome to SilviCast, the podcast about all things silviculture. My name is Brad Hutnick.
And I'm Greg Edge.
And we're both silviculturists with the Wisconsin Department of Natural Resources, Division of Forestry, and your hosts for today's show.
So, Brad, what you doing today?
Well, I don't know. I've just been looking at some podcast rankings, kind of looking at that stuff. And I don't want to surprise you.
How do we fall?
We don't even make the list.
What?
Can you believe it? I mean, I would have thought we would have been right up there with the Kelseys and with, I don't know, like all NPR. I mean, what's the difference between us and NPR? We should be right up there.
The Kelsey podcast ranks highly?
It does. It does. And I'm not even sure how high it is, but we can't see it from where we are in the rankings, Greg.
Oh. Well, I guess I can see that. They're kind of more popular. They do have Taylor Swift working for them. So I think, Brad, if you could just date Taylor Swift, we would get a ton more downloads.
I think you're right. I know you're right. There are a couple problems. There's just a couple little things that kind of like make that problematic.
Yeah.
I don't know. One is about like the league that she's in versus, me, a simple dirt forester.
Yeah. Yeah.
And I would probably, getting a divorce. I like most of my things right now. So that's probably, I don't really want to get rid of everything, but.
And you're really old too. I mean.
And I'm not as old as you.
Travis Kelce could just really pound you into the ground.
Yeah, I'm
okay. That's not going to work. We've decided we're not going to go there.
No.
I think another way, they also ranked really well the other week because Jason Kelce went shirtless at the Chiefs game. It was on national television. So maybe you could do that.
I think you might have something for that. But we got to figure out where we can go. Like we could both do it, right? We could both go shirtless.
No.
Like maybe at the next SAF meeting, we'll both just burst in like, go SAF. Yeah.
Yeah. And that'll end up on national television.
Well, yeah, maybe we'd find 5 more listeners.
Okay.
But, it's all gimmicks though, right?
It's something like you've told me, Brad, over and over again. What is it? Don't compare yourself to others. That's not the secret to happiness or something along those lines.
My God, you listen to that. Oh my God. It's taking seed. I'm making progress, Greg. You just made my day. That's fantastic.
Yeah. Okay. Well, I try to listen once in a while.
Yeah.
So, Brad, I think all we really need to concentrate on is just keep providing good silvicultural information to the field, and we'll be just fine. We don't need to rank up there with the Kelsey brothers or the Daily. You're just not going to get there.
Well, it wouldn't be bad if we were there, but it's no great dishonor either, right?
Yeah. That's exactly what I'm saying. And take today, for instance. Today, we're going to talk about a really important topic, much more important than the Chiefs game, and that is the introduction of emerald ash borer into North America, its impacts on the forest, and what foresters can do to work with this invasive pest. So that, is really important. We're going to talk about beetles today.
Oh, and I get to use my beetle jokes?
Okay.
All right, excellent. Here we go. Giddy up. And I've had this list on my desk for how long, Greg? Like, I don't know. It's just you got to use them. All right, here we go. What kinds of beetles are no fun at parties?
Dung beetles?
No. Boring beetles.
Oh.
See, get it? Okay, this one is beetle, but what did one female firefly say to the other?
Oh. I don't know.
You glow, girl. Get it? See, this is good stuff. This is good stuff.
Cut.
All right, well, okay, one more.
Okay, one more.
Answer the bug joke. Okay. Why did the entomologist choose the rice weevil over the acorn weevil?
I don't know.
Because it was the lesser of 2 weevils. Yeah, get it? It's good. See, we're going to be right up with the Kelseys now.
I think the qualifier on getting higher podcast rankings was to put out quality, and I just don't think that that's there, Brad. But if you want quality silvicultural information, You won't be disappointed with today's discussion about emerald ash borer, because today on SilviCast, we'll be exploring the latest research on this invasive pest and management strategies around it with Kathleen Knight and Jennifer Koch, both leading researchers on this insect, and both work at U.S. Forest Service's Northern Research Station in Delaware, Ohio.
This should be a fascinating discussion, and they will appreciate my jokes.
Just keep them to yourself, Brad.
This season of SilviCast is brought to you by the Nelson Paint Company, McCoy Construction and Forestry, and the Family Forest Carbon Program. You make the SilviCast world go round, so thank you. Kathleen Knight, Jennifer Koch, welcome to SilviCast.
Thank you.
So before we get started, maybe you guys could tell us a little bit about yourselves, where you work, what you do, things like that.
Sure. So I'm Kathleen. I'm a research ecologist at the U.S. Forest Service Northern Research Station. The Northern Research Station is an area from Minnesota to Maine with a lot of different locations where people work. We are based in Central Ohio in the town of Delaware.
And my name is Jennifer Koch, and I work at the same facility as Kathleen, part of the Northern Research Station in Delaware, Ohio, a little bit north of Columbus, which is probably a city people have heard more of than Delaware. I think I mentioned I'm a research biologist, but my background is in molecular genetics. So I work both with traditional genetic approaches to breeding, as well as mostly through collaboration, adding some of that genomics type of research to it.
And Jennifer, you and Kathleen, you've both studied emerald ash borer for numbers of years now, because I've been reading your research and the different things you're doing and seeing you at meetings. Just so I understand, you both specialize a little bit. Kathleen, you more look at the ecology of emerald ash borer, whereas Jennifer, you're involved in the genetics and the breeding and the resistance. Is that correct?
Yeah, that's correct.
That is correct.
Okay.
And we work together a lot, but we each have our field of expertise, which is
right.
Really complementary.
It's actually Kathleen's early monitoring work, trying to understand what was happening when EAB was going through natural stands, that got us honed in on the idea that there may be natural resistance in some of these trees.
Well, we've had emerald ash borer here in Wisconsin. I don't know, Brad. We got it in about 2007, I think.
Right.
And just like everywhere else, our foresters have been struggling to catch up and deal with this insect and the impacts in the forest, and always have questions around like, what next? What do I do? How do I approach these stands? So we thought it'd be great to have both of you on and kind of talk about what the research is and what maybe some of the management direction we might be going is with that insect. But before we go there, I thought it'd be good to paint a little bit of a picture of about where we're at with this particular invasive insect. It's been here for 20 plus years, and kind of what is its status right now in North America?
So it has spread throughout our region in North America and also into some more southern states. And it's also made a big jump out to Oregon.
Oh, really?
So it's really gotten around over the past 20 years. It's expanded. And of course, in all of these ecosystems where it's been introduced with the many different ash species that we have, it's really had major impacts on the ash species in those systems, just killing a very large number of ash trees.
Has anything changed? I know, and Greg, I recall being a young forester and hearing about emerald ash borer, and it was kind of like everyone dies. And so I've always wondered about that differential rate between the different species. Is there anything new on that, or what does that look like now?
Well, I was going to add a little bit to the impacts of it first, just to give a little bit more context about how serious it is. So, I mean, based on Kathleen's studies, up to 100% of the ash were killed within a short number of years.
Yeah.
But where we're at now is that we have 16 species in the United States. 9 of those those species are in what is considered the infested range right now. And the infested range covers 480 billion hectares. Not the infested, I'm sorry. The range of all of the ash species covers 480 billion hectares, and 40% of that range is now infested. And that includes the jump to Oregon ash that Kathleen referred to. But as far as the differential between species, green and white are both highly susceptible. We see some differences, but I don't think Kathleen's data, so she can say more towards this, is really showing a higher percent survival in white ash, but she is seeing that in blue ash, and our studies are confirming that. Pumpkin ash and black ash, I can talk about black ash and go into more detail about that later, but they're also both highly susceptible.
So the picture hasn't changed. Essentially, we've just learned more about the mortality, but essentially it's pretty consistent throughout most of the ash species.
Yes, and I would add it's the larger size classes that are most heavily impacted. So, anything, bigger than 4 inches DBH has a very high mortality rate. They can infest trees down to 1 inch DBH, but they seem to prefer the trees to be at least 3 inches. So you do get, everything less than 2 inches or so, you have a lot of trees surviving in that smaller size class. But as they get into those larger size classes, they really have a very high mortality rate for all of the species except blue ash, which still gets killed. There's still a lot of blue ash that does die, but they're the ones that really stand out with a greater survival rate.
And I just want to add one other caveat to this from a genetics perspective, is that the data that we have is from a limited area, and these are very wide-ranging species. So we can't just extrapolate the mortality rates that we've seen across every population across these huge ranges. Although it seems likely that we're going to see a lot of mortality continuing in green and white ash. I think things like blue ash, we have some preliminary data that shows that there's some population differences where you can find populations that have higher levels of resistance than others. But we may see differences as the story continues.
And Kathleen, you've studied kind of that core area in Ohio and lower peninsula of Michigan that's had EAB the longest. In that area, has EAB's population moved through that first wave? Have you seen kind of the majority of the mortality you think you're going to see? Or what happens with that population of EAB after that?
Yeah, so I set up monitoring plots across Ohio starting back in 2005. We also have some monitoring plots in southern Michigan as well as northwest Pennsylvania. And we've seen the first wave come through, kill off over 95% of those large size class of ash trees. With blue ash, it's only killed off 30%, but with the other species, it's killed off a higher percent. And so that was the larger trees. We do see on the landscape after that first wave, emerald ash borer populations do crash to low densities. They're still around. We're still catching them. We trap every year with the purple panel traps in all our sites that we're doing that long-term monitoring. And we're seeing emerald ash borer populations persist over time. There are small ash trees remaining that were too small to be preferred during that first wave. And a lot of those, if they've ended up in a gap, they grow larger fairly rapidly. We also have all of the rare lingering ash species on the landscape that survive that first wave, may have some resistance to EAB. Those continue to persist and grow. And then we're actually now seeing a second wave of EAB. So those small ash trees have gotten large enough that we have plenty of host material on some of these sites again. The lingering ash have grown larger as well. And some of those lingering ash may have moderate levels of resistance that allow them to survive at, low or moderate pest pressure, but then they might die at higher pest pressure. And so that's what we're seeing now in the second wave. Some of those lingering ash trees are dying, some of them are surviving. And a lot of those smaller ash that have now grown into that larger susceptible size class, they're getting killed too during the second wave. So it doesn't seem to go away. It doesn't seem to disappear from the landscape. And that fits with some of the modeling that Rachel Kapler's done, looking at population viability analysis of surviving ash after that first wave. If we have repeated bouts of EAB over time, you may get extinction later, and her models predicted local extinction of many populations within 35 years of that initial infestation.
Huh. So I guess that was one of my follow-up questions is, as this smaller sapling, seedling size class gets into that bigger size class, and you say the EAB populations uptick a little bit and start to hit those, is there anything coming in behind those? Then what happens to the EAB population there if there's nothing coming in behind those?
Right. We've got to keep monitoring and understand how that plays out on the landscape. The ash species that I'm looking at, white ash and green ash in a lot of these sites, is fairly shade tolerant, and there's still a lot of very, smaller seedlings, still too small for EAB, persisting in that understory. So we may see this repeat itself a number of times with those smaller seedlings. Some of the lingering ash got large enough to reproduce and produce seeds. Some of the sites in Michigan that Dan Cashian studied, ash that was killed was able to resprout from the stump and grow back, kind of like American chestnut. So it'll be interesting to see how this plays out over the very long term in terms of repeated bouts of EAB coming through and affecting these populations. You'll also have shifts in the populations over time to more of the individuals that have resistance. So that will play a role too in how this plays out on the landscape. But I think regardless, I think we can say that these populations are in trouble.
Mm-hmm.
And that shift to resistance over time that Kathleen just referred to, that's where the breeding work comes in, because you're only going to see that shift if these resistant trees are able to cross-pollinate with each other. And they're so rare that many of the plots that Kathleen worked in, there were no surviving mature trees. So I was at a meeting once where we were discussing this, and one of my colleagues came up with, I was explaining how we have to find the best trees and bring them together. And he coined the phrase like tree harmony, where you're trying to pair these trees together. So with breeding, in the case where something like emerald ash borer kills off so much of the trees, and the really resistant trees that could potentially contribute to a breeding program are so far apart that they probably can't even find each other to cross-pollinate. That's the job of a breeding program, is to preserve those trees and bring them into plantings where they are closer together and eventually develop seed orchards.
Jennifer, maybe just backing up a second. So we have listeners that'll be in that range where they don't have EAB yet. We have listeners where we're just getting it. And then now we have listeners where, we've had it. We're getting that second wave. And so we've talked about lingering and resistant. So it might be good to define those. And I heard you use a phrase that I thought was really good, where all lingering ash are resistant, but not all resistant trees are lingering. Okay, probably should have had another cup of coffee this morning. What I should have said are not all lingering ash are resistant, but all resistant trees are lingering.
That is correct. So we very intentionally coined the phrase lingering ash because we were trying to be very cautious. We got excited because of Kathleen's data, where she, at some of her plots, was finding trees that were remaining healthy, even though the modeling was showing everything should be dead by then. And to us as geneticists, we thought, well, this could be genetic variation, a rare form of genetic variation within the population. But the entomologists were saying, well, some tree has to be the last tree to die. So this tree could go on to die. And at the same time, there were programs like what's going on with the American Chestnut Foundation. At that time, they were finding out that the expected close to, 80% or over 50% of their seedlings at that particular generation were supposed to be resistant. Only about 17% were showing resistance, which from a geneticist standpoint, 17% is actually really good for a breeding program at that point. But people felt a little bit disappointed. So we didn't want to say anything about resistance until we had gotten a chance to get more test results. So we were just talking about it, and Mary Mason in my lab talked about, what about the word lingering? Like when you're having a party and there's that one person that just doesn't want to leave. And that's what we went with. And it seems to have really taken off because I hear it used with lingering hemlock now and all sorts of species. And the other difference too, because I know Kathleen, she works with elm and they talk about survivor trees. These are trees too that we clearly knew that there was signs that they were getting attacked by EAB. The canopies were remaining healthy, but we could see injury. We could see healing over injury. But what we're doing is taking the lingering ash trees that we find in natural forests, guided initially primarily by Kathleen's monitoring work, grafting them, and they become potted trees that are a copy of that tree that was in the woods. We test those grafts. We also use those for breeding, and then we test the seedlings. And our bioassay, what we're looking at specifically is putting eggs on the trees and waiting for larval development to take place for a period of time of about 2 months. And then we're dissecting out and finding the larvae to see, did it develop? Does it have delayed development? Was it killed by a host defense response? And we're seeing the same host defense responses in the mature trees, in the grafted trees, and in 2 and 3-year-old seedlings that we're testing.
In that research, can you say anything about what we found about the level of resistance between, say, natural populations of the different species? Like, what are we talking about for level?
So what I can tell you is with our bioassays, the best performing lingering ash tree that showed resistance in our bioassays that we selected directly from a natural forest killed 45% of the eggs that we put on it. When we tested unselected seedlots, the best performing seedling from those seedlots, which would be presumed susceptible, was to be able to kill about 10-12% of the eggs that we put on it. So, that's a 30% gap. So when you think about if even 1 out of 4 larvae is killed, that's 25% less damage to that tree, which is going to be enough to allow it to live longer.
Pretty good.
And that's why.
Is that green ash?
Yeah, that's green ash.
Okay.
I was going to say too, I saw a presentation and I came out of it, and one of the things I took from it that you said was that breeding works, right? So there has been progress on your part. Could you tell us a little bit about that?
Yeah, we're very happy to. We've had some really exciting results. We've screened at least 27 families now, and trying to think, about 21 of those families produce progeny that perform better than either parent. And we are seeing some families producing progeny that are in the range of killing EAB up to 85 to 100%. And I specifically chose 85 to 100% because that happens to be the range that we typically see when we test Manchurian ash as a resistant control. Manchurian ash is an Asian species that's co-evolved and is highly resistant to EAB. It doesn't usually have any problems with EAB unless there's a big drought event or something like that. So some of the seedlings from our breeding program are testing by our bioassays just as good as Manchurian ash, the resistant ash. Now, these are bioassays. They're done in controlled greenhouse conditions. These are potted trees. So we're taking everything out to the field to test as well, because there can be environmental impacts that can affect levels of resistance. So we want to make sure. But our hope is that we can take the idea is that we're trying to find as many lingering ash parents as we can from a specific region and crossbreed them and select the best progeny from each of those crosses, maybe the top 10% or something. I haven't quite figured out exactly. We're in the proof of concept stage right now, and plant them out into a seed orchard. So these trees in the families I was just describing to you that are killing 45% up to 100% of larvae, those would be put in a seed orchard and allowed to crossbreed with each other. So we anticipate that the seed that they produce would have that would be a population that has an increased level of frequency as well as an increased level of those higher levels of frequency, similar to the Asian species. And so that would be appropriate to start restoration. And just to clarify too, the goal of forest restoration breeding, which is what we're doing, it's not the same as cultivar development. We're not looking for, and we don't expect every tree to be completely immune or hit that 100% level. We don't need that. As a matter of fact, that's not going to be healthy for a forest, because that means you're probably going to limit your genetic diversity. So we're looking to keep as much genetic diversity as we can, capture the multiple mechanisms that are probably what we were discussing. Even though we're selecting based on the one bioassay, if we keep diverse parents, we're going to capture the other mechanisms as well, so that we put out what we're putting back is a population that is self-sustaining, meaning that there's enough individuals in that population that are going to survive EAB. There's enough genetic so that they can go on to reproduce and continue to evolve under this pressure of EAB. And there's enough genetic diversity so that the population can evolve as it's facing other new stressors, like a changing climate or different pests and pathogens that may come in. So getting it to the point of and that's what a typical forest species is. There's variation, but enough of them survive in most cases that they're under natural evolution and they persevere.
Those kind of levels, are you talking in green ash, and are you seeing something similar in black ash?
So most of our data is in green ash. We are getting more data in white ash. That's very similar to our green ash data. Black ash, we have not been able to do a lot of work with black ash, mostly because the areas that Kathleen was monitoring in, we don't have a high prevalence of black ash. We do have some lingering black ash that we've tested that performed quite well. And we also did a really interesting study lately where we didn't know anything about population diversity in black ash in regard to EAB at the time. I've seen studies where people are quantifying and saying and watching it as it all dies, and it all dies. But like I said, our lingering ash die too. It's more a question of how much longer does it take them to die? And as Kathleen said, in many cases, those healthy trees continue to live, but not all. So we didn't know. So what we did was we took some seed lots that were collected before EAB infestations had occurred. So they were unselected seed lots. Again, with the rarity of resistance, we would expect that those would be mostly susceptible. But we had 6 seed lots, and we screened them with our bioassay, and we were able to find resistant trees in 5 of this out of 6 of those seed lots. And in addition, we found resistance levels in our bioassay that ranged between 45 to 75% tree killed. And that's without waiting for all the black ash to die. So that gives us some hope that there's a chance of being proactive about black ash and getting seed collected and starting to screen these seed and starting to get seed orchards in place now so we can actually be producing improved material before EAB has had a chance to go through the entire range of black ash. There is, again, there's always a sort of like a caveat, but the other thing we've seen with black ash is that in some cases, the ability to kill larvae does not always equate to better survival. And this has been recorded in the field because in the field they find that it takes fewer larvae to kill a black ash. What we're seeing in our bioassays is what we think is a resistance response that becomes detrimental to the tree. In other words, it's uncontrolled. So typically a tree will try to wall off the infection of the insect. And in this case, we see killing of tissue far beyond where the insect is. So the other thing we did was we did the same bioassay on seedlings, and instead of dissecting them at 8 weeks, we left them for a year. And we found about, 1 in 25 survived. And we're using doses that mimic that highest level of EAB at the killing front. So survival rate of 1 in 25 is far better than what we have seen with green ash and white ash. So it still gives hope for that proactive breeding approach.
Well, that's good news for our black ash and our foresters out there who are really concerned because we have these large levels of black ash, especially across northern Wisconsin.
Looking for continuing education credits? Check out the SilviCast webpage for more information. And now, back to our show.
I know our foresters are going to have a lot of questions about sort of the management aspects of this. And I know, Kathleen, you've worked a lot in this area and talked to a lot of our foresters. And I kind of want to just start out this conversation with when we first got this problem, there was this whole idea of we could maybe cut our way out of this problem by cutting as much ash around these infested areas as possible. I believe that was called phloem reduction. So has that idea been put to rest?
I'm glad you asked about that. There's been so much confusion on that. So, at the very beginning, whenever an infestation was discovered, they would try to do an eradication cut of all ash within a half-mile radius to prevent emerald ash borer from spreading further. But the species is so hard to detect early on that by the time you've detected it here, it's already 20 miles away. It's already spread from there. And so that did not work. They put a lot of effort into it, did a lot of cuts. The cat was already out of the bag. So that was not successful. The next thing that came up was this idea of phloem reduction to slow the spread of EAB, with the idea being that you could kind of EAB proof your stand by reducing the amount of ash in it, not cutting all of it. And that would, once emerald ash borer got there, that would slow its spread through that area. And the monitoring plots that I set up actually showed the opposite. In stands that had a lower density of ash, so mixed species stands with more other species mixed in, the ash trees died faster than stands that had a high density of ash. So it's just the biology of the insect. Not everything is a pine beetle. So reducing the density of ash in the stand alone is not a good way to slow the mortality of ash of the other remaining trees. Those will still die and may in fact die faster. It also, in modeling, it showed maybe it slows the spread of EAB beyond that stand. I think the jury's still a little bit out on that as well. There are some really good reasons to cut ash, but slowing the mortality of your remaining ash trees is not one of them. So you may want to cut ash in your stand if you have very large trees that you want to get commercial value out of before emerald ash borer comes through and kills them. You may want to cut some ash trees in high use recreation areas before they become hazards if you don't plan to insecticide treat those trees. So that decision has to be made beforehand. And there's been a number of people doing some really wonderful and creative work thinking about what to do with these stands in terms of getting diversification to happen, getting other tree species into these stands. So, doing strip harvests of ash so that other trees can fill in some of those areas, maybe underplanting and doing some cuts in these really hydrologically sensitive areas, especially with black ash, to diversify the stands. And that's totally reasonable. That's really, that's really smart to be thinking in terms of that. So, there are ways to slow mortality of ash. I know the Twin Cities did a really concerted effort to, once emerald ash borer had gotten there, so not preemptive removal of ash, but once it got there, removing infested ash trees that showed signs of infestation and chipping them up. And they found that they probably slowed emerald ash borer by about a year or two by doing that effort. So they bought themselves a little bit of time for treatments and other planning. There's also use of lethal trap trees where you select some ash trees in your stand, insecticide treat them, let the insecticide go through the tree, and then girdle them to make them super attractive to EAB so they kind of draw in all the EAB to that tree and kill it. So that may allow some slowing of EAB infestation as well, if that's a route you want to go. So there are some options, but our thought on that whole paradigm of let's reduce EAB spread by just reducing ash density in the landscape, that is no longer what we're recommending.
I can hear foresters talking about this and saying, okay, this is cool. I'm in front of emerald ash borer. I have an ash stand. I may not be coming back for 15 years or 20 years afterwards. So it's a catch-22. If I take all the ash, well, then I don't have any chance of resistance, right? And so is there a good way to say, hey, yeah, you should keep some of the ash, or like a good decision? Like, how would you decide which ash to keep, or maybe a certain percentage, or is there any guidance on that?
I don't think there's any guidance on, what percentage to keep. It really depends on the landowner's goals and the specific situation with the stands. I will say that with white and green ash, the stands where we are finding lingering ash are stands with canopy codominant or dominant ash trees that are 12 inches or less DBH. So these are younger forest stands that have that kind of, they're mature trees, but they're a smaller size class of mature trees. And that's where we're finding most of the lingering ash. So I think that's a good place with white and green to be thinking, gosh, maybe we should keep some of those areas so that we can look for lingering ash. We have unfortunately not found survival of ash trees of those very large size class ash trees. I mean, the Allegheny National Forest just had absolutely huge white ash trees in a lot of their stands, and those died. We don't find any lingering, just monster huge trees. And that doesn't mean that there's not resistance in those trees. It just means that during that first wave, that really high EAB pressure, we're not able to parse out those subtle differences among those large size classes like we are in those smaller, vigorously growing size classes. So that's what I would recommend there. With black ash, I don't know at this point, where we found so few lingering black ash in the field that because we're at the very southern edge of it. It's just in a few little tiny spots here and there in Ohio that we monitored, but it's not the same as having, on a landscape scale, as much black ash as you guys do. So I think it's important to watch. I think it's important to make observations in the forest, see where we're seeing survival, see where we're seeing some trees surviving noticeably longer than others, even if they do go on to die. As Jennifer pointed out, those trees are still valuable if they're able to survive a bit longer. So just making those observations, I think, is really important.
Kathleen, I wanted to ask you about timeframes because since we are on sort of the front of EAB in a lot of parts of Wisconsin, and our foresters are thinking about those decisions about what do we keep, what stands do we salvage. It's good to know sort of like what kind of time frames they have in terms of the rate of infestation and mortality. And I think you've learned some things about that through looking at these monitoring plots. Is that correct?
Yeah, so in our stands, we found it was about a 6-year time course between when emerald ash borer was first found and when you reached that, over 90% mortality kind of stage. So in the first few years, EAB is ramping up slowly. It, probably goes after the most stressed and most attractive trees at that point and reinfests those. And then, so you're not seeing a huge amount of mortality in those first early years. And then it's, exponential population increase, right?
Mhm.
So it really can ramp up. The emerald ash borer populations peak when you have about 50% mortality. So you'll kind of get a year where you really start to see mortality suddenly ramp up throughout the stand. And you've got 50% mortality of your ash. Within a year or two of that 50% mortality mark, you're at, kind of the end point of 90%, 95%, 100% mortality of the ash trees. And at that point, the EAB populations have crashed. So it's very similar, very predictable in all of the ash stands that I was monitoring, regardless of species. And as Jennifer said, the only species nuance would be in stands that have a mix of white ash and blue ash. You first see that very typical mortality trajectory with the white ash. And then after the white ash is dead, you start to see the mortality of the blue ash trees. So in those stands, it's like all of the white ash trees are dead. All of the blue ash trees are still alive. And then you start to see mortality of some of those blue ash. So you get kind of a double trajectory in those sites. So we do see that very typical time course. And then in our Ohio sites, it seems like, around the 10-year mark is when we start seeing that second wave of emerald ash borer come through. So you kind of have a lull where whatever you're left with, by that first endpoint, those surviving trees that still look healthy seem to tick along healthy for, about a decade. And then you see that upswing of emerald ash borer again in our sites. But of course, we've only looked in these Ohio sites and Pennsylvania sites and Southern Michigan at this point. So there could be some nuance and some difference as you get further north, especially as you get further north and more of the emerald ash borer is in a 2-year life cycle rather than a 1-year life cycle. There could be some differences in that time course up there.
Mhm.
Oh, I was just going to add, if there are, forest managers who are interested in more information or who are interested in reporting lingering ash, that's something or how to find lingering ash. And if they're not sure about what they have is lingering ash, along the lines of, yes, if they have an area of the forest they're managing that have, a high density of ash that they can just let go, that would be great. Certainly want to avoid hazard trees like Kathleen was talking about. But we do have some resources for people. We're trying to expand our efforts because what we're doing, we keep saying, going back to, oh, it's Ohio, Michigan, it's very local, or Pennsylvania, it's very localized. And in order to restore even the seed orchard that we're doing as proof of concept, that's only going to be appropriate for the areas that they came from. And maybe if you want to do some assisted migration, the areas that are just adjacent to the north. So we need to replicate the work that we've done throughout the range for each of the species, which is going to take a whole heck of a lot of partnerships. So the things I wanted to mention were the Tree Snap app. That's an app where people can report lingering ash. They can report all kinds of ash and give information about the health of those trees, but that helps us as researchers find more, or other breeders or other, state forest nurseries or national forest nurseries who are wanting to establish seed orchards find select trees. So that's treesnap.org. And there's also monitoringash.org. It's run by the Ecological Research Institute. They worked a lot with Kathleen and I. So based on our research, created a series of pretty much citizen science trainings that from monitoring for EAB to monitoring as EAB comes in, monitoring to identify lingering ash, and if you're in the right areas, how to find and report lingering ash. And that's mostly in the New England area. We also have something called Great Lakes Basin Forest Health Collaborative. That is a Great Lakes Restoration Initiative project that's been funded with Forest Service and Holden Arboretum. Rachel Kapler is the coordinator right now, and this is a tech transfer effort, and it's also a breeding networking effort. So the effort is to provide people with the information they know. Again, all of the trainings, it covers more species than just ash. There's videos on the website. If you Google search just Great Lakes Basin Forest Health Collaborative Holden, you'll be able to find it. There's videos you can look at, video trainings. And we are trying to get funding. It's looking promising to establish another coordinator for that collaborative in the state of Wisconsin.
That's good news. And the Tree Snap app, that is available through the different through all the different places you can get apps, correct?
Yes, it's available for free.
And we can put that information on our show notes too, so foresters are interested in that.
Yeah, and I've used it in the past in the field, and it's really quick, it's really easy, and you could do it right when you're at the tree too. You don't have to come back and think about where it was or go back to the website. So I thought it was really good.
Yeah, you don't even have to have cell service because it'll save your entries until you have cell service.
Giddy up. Yeah.
So should foresters who are maybe past that initial wave, I know in southern Wisconsin we're probably getting close to that 6-year mark, Kathleen, where we have lots of mortality, especially in our southeast. That's when would be a good time for them to identify and monitor and record healthy lingering trees.
Yeah, we typically say you want to wait at least 2 years after you've hit that kind of endpoint 90% mortality mark, or 4 years after the 50% mortality mark. They're usually about the same time to start looking, just because you don't want to get the very last trees in the trajectory of that first mortality wave. And at that point, I think you're right. I mean, there's a lot of areas that have hit that mark that are ready to get out and start finding these trees, and especially black ash. We need people on the ground finding ones, even trees that have survived a bit longer than the others can be quite valuable for the program.
I would encourage seed collection for black ash as well. It doesn't seed as frequently as the other species. So if there's a chance to get black ash seed built up, that would be a good thing. But yes, and the other thing is, if people that are, trained professionals that are managing land resources associated with an agency, if they can put that agency next to their name in TreeSnap, that helps us coordinate better with various state and national forest partners or even parks.
I think it was a talk one of you guys gave a long time ago, but like when you see the map of infestation, you kind of see it kind of advancing in this uniform spread. But then in reality, it's much more patchy. So you have skips and gaps and jumps. And so foresters might just not have gotten there, even though they're well behind the line of that advance. But no fault, still report those. It's quote unquote lingering, but maybe it hasn't gotten there, or what I'm saying is, if you have any doubts, still put the reports in, correct?
I would say yes, because it'll ask questions like, for example, it'll ask, what is the condition of the next nearest 10 ash trees surrounding you?
Yeah.
So that gives us an idea. Like if there's other healthy ash, it'll ask questions like that. What's the condition? And the other thing I would encourage is repeated reports on the same tree. And there's a way to do that. It should be explained in the app. And if it's not, to enter it again on the following year.
Yeah.
Because like Kathleen had mentioned, there is this, sometimes in a single year, you can have 50% healthy ash, and by the next year, you have dropped down, I don't know, to like what, 10%?
Yeah.
And when you're at that point, you can go in and you see over half the trees, a good chunk are dead, another good chunk are very much in decline. And and so when you see a healthy tree, you get really excited. But if there's not enough mortality, it's very likely that a bunch of those healthy trees are going to be dead the following year. So the best way is to give repeated observations, annual observations on the health of a tree that you report. Because, I mean, honestly, we don't have the bandwidth to do anything with those trees right now. People might, depending on if it's private owned, whatever, you can think about insecticide treatments. But at what point? Because we still want to see how healthy is this tree going to stay on its own.
Yeah.
So more information is always better.
I think these are the most common questions I get from foresters. They're thinking about these levels of resistance, but they're also thinking about the economic value of these trees in the forest. And so they're trying to weigh these questions about, what do I keep? What do I salvage? That sort of thing. Do I leave ash within those stands? And I think some of that timing information, Kathleen, that you provided is helpful, because they can plan out. But I know you also did some research looking at just the impact on the other species within those stands where ash has died, and those respond to that basic thinning of those stands. Is that correct?
They do. And it was really interesting to me. It's not a disturbance like a commercial thinning or a blowdown that happens instantaneously, that where you go from having these trees to not having them. So they are, they're declining over a period of a few years. And that really gives if you have a good mid-story of other tree species beneath this canopy of ash, that gives those trees the opportunity to start growing in lockstep with the decline of the ash trees. So the ash tree canopies are thinning, a little more light's getting through. The ash aren't, as they're slowly getting girdled, they're not taking up as much water and nutrients from the soil, so the below ground competition decreases. And that gives those other trees a chance to respond. And we really saw that. I had a graduate student, Kyle Costello, who's now with APHIS, do a really cool study looking at growth rings of silver maple and red maple that were beneath the canopy of green ash and black and pumpkin ash in Northwest Ohio. And what he saw was, the growth response occurred long before those stands were completely dead. The trees were not waiting for complete mortality of ash. They were already responding as the ash trees started to die. And because of that, in a lot of those stands, we didn't get a big burst of light to the understory, which was something that we worry about with invasive plant species. Because if you have invasive plants kind of lurking in your understory, and you suddenly get big gaps opening up, those invasive plants can take off and become a problem for regeneration of tree species. So having this disturbance play out more slowly, allowing those other trees to fill in, we were measuring light levels in the understory, and a lot of these stands, we did not ever see an increase in light. In fact, some of them just slowly got shadier over time because maple canopies are a little more dense than the ash canopies that had been there before them. So I think really assessing your stands beforehand, understanding what is in these forest stands. Do you have areas that are just a monoculture of ash that you don't have adequate regeneration of other trees that are going to fill in the gaps, and you might need to consider underplanting if you're going to keep that land in forest, versus are there a bunch of kind of spindly looking maples and elms hanging out in the mid-story that are poised to fill in those gaps as the ash dies? That's a really important consideration for what your management of that stand could look like.
That sounds a lot like spongy moth in the east, where as the oaks died, it kind of released that mid-story and it kind of accelerated succession to say red maple or other things. I'm curious
Yes.
in this situation, so I could see advanced regeneration getting released by that slow light, and you would kind of get some of that. Did you see new seedlings kind of coming in at that same kind of the same response, like a new regeneration cohort coming through?
We were monitoring seedlings and monitoring new seedlings. In most of these stands, it was the advanced regeneration. When I said regeneration, it was mostly the trees that are already kind of in that small sapling stage
Yeah.
in the mid-story of these stands that really benefited, because we didn't get big gaps opening up. So you would need in some places that we didn't have those that a bunch of saplings in the mid-story, we did get gaps opening up. And in those places, yes, you could have new seedlings taking advantage of those gaps. But in the places that had some mid-story there and the gaps opened very slowly, so the mid-story was able to shoot up, it really didn't give a chance for new seedling regeneration to really advance because of that.
Another thing I noted that you said, Kathleen, is once that EAB population starts to exponentially go up, that mortality can occur quite quickly. And that
Yes.
has some implications for salvage. Have you seen these stands deteriorate or these trees deteriorate quickly, making it difficult to salvage?
They really do. So, once you get to that rapid mortality stage, you can have trees that look healthy go to dead by the next year. You can go from 50% mortality to 100% mortality in a year. And once the trees are dead, ash actually becomes very brittle very quickly, much more dangerous to try to fell those trees, because it doesn't do what you expect it to do when you're cutting it. So it can be a consideration. It was actually, I'm trying to remember the person at the University of Minnesota that did a really cool study that showed that emerald ash borer is actually introducing decay fungi through its galleries as it infests the tree. And that is likely what's contributing to this just rapid, deterioration of these trees once they're dead. They don't hang around very long as dead standing trees. They really break up and fall apart quickly, and become, hazardous if they're in high use areas, or if you're trying to cut them after that mortality. So making sure to have a plan ahead of time if you're going to salvage, early, rather than waiting until you have a bunch of dead trees.
Yeah, and that kind of goes to that whole idea of assessing your stands as soon as you can, trying to make those decisions based on that composition and objectives for those stands. But yeah, that's what I've heard is once it starts to go, then it loses that really safety factor and actual economic value quite quickly.
Mm-hmm.
I think, foresters in the field are going to be just looking for that kind of information about just how to approach these stands. I can see there's a lot of questions already with us in Wisconsin and Minnesota with these large black ash lowland stands that we have. So just these management questions that you're both working on are really important. I know Jennifer on the breeding side, that's always a question we get with foresters, like, are we going to have stock to do restoration efforts? And so they're very interested in that breeding program and those levels of resistance. So I just wanted to say I really appreciate the work that both of you are doing, and You're getting out and talking with our field staff. It's just kind of helping them manage a very difficult situation. And they're going to continue to have questions for you. So I just want to say thanks for providing that information to our staff.
And I take from this conversation that there's hope, right? Like it might not be super strong right now, but there is hope on the horizon.
Absolutely. And we didn't talk about, there are other management tools that can be used in conjunction with resistance as well for kind of integrated pest management. So we've come a long way since I was just monitoring the plots and cataloging the death of the ash trees. And I had really depressing talks that I gave where I said, everything is dying and it's terrible. So we've come a long way where we know we have resistance, and we have these resistant trees that we can use in a breeding program to produce even better resistance that could then go back out onto the landscape eventually once we've got seed orchards. There's good research on biocontrol insects. There's good research going on with genetic conservation, either through insecticide treatment or seed collection. And then, management options in terms of underplanting and how to go about that, how to do restoration in these stands. So there's just a very hopeful suite of information now that's out there that's much better in terms of communicating than just saying, well, I'm watching it and everything's dying. So it's nice to have that more hopeful message to give to people.
Absolutely.
I take away from this conversation too that field folks, managers, foresters can take a real active role in this, right? in helping to identify these lingering ash, working with folks like you and communicating that information through things like tree snap. So there's things that they can do to help that whole process.
Yes.
Absolutely. Absolutely. And we want to hear what people are seeing on the ground too, in terms of observations of what's happening in these black ash stands further north. That's going to help shape our thinking and what we recommend for people to do in terms of searching for lingering ash.
Yes. I mean, there's definitely optimism. And the really cool thing about it is the interest from land managers, landowners, private citizens, all sorts of different groups. And it's those partnerships that have helped us do what we've been able to accomplish so far. And it's those partnerships that we're going to depend on to get us the rest of the way there.
What this does is it brings me back to, if forestry were easy, we wouldn't need foresters. And so this is a perfect opportunity for thoughtful practice by people in the woods to prove the need for forestry and foresters.
Absolutely.
That's an excellent point.
Jennifer, Kathleen, thanks for joining us on SilviCast.
Thank you.
Thank you so much for having us.
That was a great conversation with Kathleen and Jennifer.
That really was.
And I was thinking about that term, Brad. We learned a new term today. Well, if you didn't know it, and that was lingering ash and specifically what that meant. So I was thinking about terminology, and you and I both, love silvicultural terms, right?
Well, we geek out on silvicultural terms.
Yeah, we do. Yeah, so, I'll admit that. I own that.
Yeah. Own it proudly, Greg.
So this year on SilviCast, I thought we should have a new segment. Maybe we tried this before, I can't remember, but we should try this new segment again and just look at really interesting and important terms in silviculture. So I'm going to call this segment Silvictionary.
Silvictionary. Okay. Did you come up with that yourself?
Well, it was either that or Silvosaurus.
Silvosaurus.
Which I liked. It had a nice ring to it, but I thought it sounded too much like a dinosaur.
Yeah, sounds like something they dig up in the La Crosse area. We found a Silvosaurus. It only ate trees.
So I was thinking about that. We already talked about lingering ash. So what will be our first term on Silvictionary? And I thought we could talk briefly about the ever popular term, because foresters always laugh at this term, and that is Femmelschlag or Femmelschlag. I don't know. I I ran it through the German translator and it sounded more like Fimmelschlag.
Well, it's kind of interesting too, because this takes us all the way back for forestry, it takes us back to those Central European and German roots of all the systems that we kind of imported. And this is just like one of our late imports from Europe into our conversation.
Yeah, and it's an old terminology. I had a text going back describing this, maybe not in the exact context we talk about it today, but back to the 1700s from Germany. So it is really interesting.
Is your understanding that it refers specifically to like expanding gaps as a system, or is it larger than that?
Well, I mean, that's what both you and I
Right.
learned when this term first started becoming popular here in North America, was also referred to as expanding gap silviculture. So creating a gap, basically creating a shelterwood sort of environment along the edges of that gap, and then going back in subsequent entries and expanding those until eventually all of those gaps would coalesce together, right? And so expanding gap is how I often hear it referred to here in this country.
And that's how I've taken it. But I think once in a while people will use like irregular as almost like Femmelschlag, irregular, like because we don't know, like none of us speak German, or at least not very many of us speak German. And so there are tons of other terms that kind of get into those specifics of all those other types of irregular systems that we still are importing from Central Europe, or at least talking about.
I thought it's interesting in this old text, it talked about, it was basically creating holes. Schlag apparently means to hit, creating holes within the canopy, and then you would get a rejuvenating center, and then they didn't refer to it as a shelter wood, they referred to it as a shield environment or something around the edges. But it's essentially kind of evolved there, it sounds like, into that same sort of expanding gap concept. It's creating small openings within the forest to get regeneration, oftentimes of sort of tolerant and mid-tolerant species, and then expanding those over time. And so it probably takes lots of different forms.
And you can see that kind of maybe being originally informed by just intuitive foresters. They would go back to those openings, they would see the regeneration in them, but then they would see that regeneration extending into that shelterwood band around the outside edges and going, oh, all we got to do is release this and we get some more. And then bada boom, bada bing, you have these larger concentric circles.
Good idea. That's all. Brad, I'm giving you a time limit on this because you could talk about this way too long.
Well, actually, what I love about this, Greg, and I think this is a discussion for all of us too, is that terminology is really important in what we do, because if we don't use proper terminology, it's really hard to convey what we're trying to use, or what we're trying to do and how we're trying to do it. And we need new terms, right? So in ecological forestry, we're embracing new terms, or at least terms that are new to us. But I think there are a whole world of terms that we should be exploring.
Sounds good. Well, we'll have plenty of opportunities on further installments of Silvictionary.
Yeah, riding the Silvosaurus.
I like that, riding the Silvosaurus.
Yeah. Thanks for listening to today's episode of SilviCast. If you have ideas for future episodes or a question for the Dropbox, please let us know. You can reach us at UW-Stevens Point's Wisconsin Forestry Center by emailing wfc@uwsp.edu. Feel free to include a sound file of your question or your comment if you like. We learn best when we wrestle with questions, so keep them coming.
Take care, everyone. And as always, thanks to our team, Susan Barrett, our editor-in-chief, Joe Rogers, our IT master, theme music by Paul Frater, and of course, UW-Stevens Point's Wisconsin Forestry Center.